Okay. So yeah, to start this thing, this is how I'm going to start it. I'm just going to review kind of my engineering documents. Maybe look at this, see what you guys have here. So like I said, I'll work about half the time here for the next hour on this particular assignment, and then I'll jump over and do some derby car setup for myself there. So I'm gonna jump in on the screw conveyor, and so the first thing I'm gonna do is I know I got to build this screw conveyor, so I'm gonna go to my resources. It's I'm gonna open up the both of these. I'm going to open up the spec sheet, which is kind of from our what I would consider like our in-house engineering and sales. And I'm going to open up the SEMA guidelines. So I'm going to have both of these documents open. I think I have mine just on my drive here for 1138. Yeah. Mine's kind of a mess. So I'm gonna don't do as I do. We're gonna do a cleaner version. Let's see. So this is my design specs. It's a Word document. Let's see. And then I'm going to open up that SEMA spec one here. Roll up this one to the top. Okay. So I'll start with my what I'm going to show you really quick, I guess, is on that SEMA spec sheet here. It's got a lot of engineering at the beginning of it. I think they even have just how you would even start for the sizing of it. Like ours, I view this assignment has already kind of been predetermined by customer sales and engineering that it's a 10-inch screw conveyor. They determined that's going to handle the product that we're going to push through it, which is whole potato is my thought here. So in the event that you were, you know, you know, in a place where you didn't have an engineer reference, this you could actually, be your own little engineer here. And if you read through this manual, it does walk you through kind of step by step on kind of the parts that would be needed and how to size parts and how to size the machinery for what you're wanting to run through it. And they have some math problems. They have a way to categorize your materials. And so that's some pretty extensive reading, and it would take a little bit to read and understand that. And so I'm not totally requiring that. But what I wanted to show you is like here's a nice little breakup view of what the parts. And mine looks very similar to this. I really just kind of stayed with what would be expected out of a SEMA standard manual here. But you can see there's quite a few parts here, and so and they're going to be assemblies associated with this, and so I'm just going to build a file structure to start housing all this stuff as I start building it. So I'm going to show you this. I'll just go to wherever you want to put this on your drive. Just start a new folder. Like mine's going to be in my lab class, and then since I'm not really divided by weeks, I have weeks in my lab class here, but I really don't have a lot in them because I think I'll end up fixing my file structure here to just kind of be the three things: the portfolio, the derby car, and the screw conveyor with some general stuff. But what I would have is definitely get a screw conveyor uh, folder set up. So here's like my new one. So if you're just building a new place, just build yourself a folder. Mine's screw conveyor for 2026. So if I go in here, I really have nothing, right? So I'm going to build a file structure. So I've got my main folder, that's my screw conveyor. Then I've got a few files that I'll need. So I'm just going to build a bunch of folders here real quick. I'm just going to build a parts folder. And I'm going to build a assemblies folder for sure. Parts. Oh yeah, you need me to get off so you can get in? Yeah. Let me stop sharing for a minute. Then, you could always build your file system however you want to and whatever makes sense to you. But this is just something that's kind of just a place to house all these things. I'm going to have drawings, of course. And I might only have one main drawing, but maybe I'll have some supplementary drawings in here. So I don't know, a folder to house whatever drawings I'm going to have. And then, for sure, at least I'll have PDFs and drawings there. And I'm going to make one more, which is just going to be kind of resources, I guess. But there'll be some information that I pull, parts that I pull from MasterCar and other manufacturers. So I'll always pull their spec sheets in there with those parts that I pull offline. And so I definitely want a place to kind of house some documents. And so just a folder, I don't know what I want to name it, but this is why I mean, if I just go back one here and I know I'm not broadcasting to your screen to see this, but you can see I should have made one more folder to house all kind of my, oh, you're gonna download step files and you're gonna download yeah, the specification sheets. So okay, cool. So I like to just build a folder for that so I don't have a mess like I've got going on my original design. So if I go back in here and add one more broadcast to your guys' screen again here. All right. I'm just going to add one more. So I got my assemblies. This old version should pop up. It's just part of I think I've if yours isn't popping up, it's probably because you haven't I think I've been in this folder and been in Inventor, and then it'll start to this is just a default folder that's populating. So I just leave that. I need one more for specifications or for, oh, I don't know what I would say. Just resources, I guess. But whatever you want to name it, just so a place I can bundle my spec sheets, step files. So at least I've got this. And then what I'm going to do is, and this is pretty common. So it can be like when you're working at a place and they have a pretty big server, they may have like a pretty big file structure that's hard to dig through. And that's pretty common, I think, in any engineering design group has a massive server, it seems like, with file structures and some of them are better organized than others. So and so it can kind of be painful to always be driving down to find where you want to save your stuff and where you want to work on a project. So Inventor has kind of a way to embed what's called just an IPJ file, which is all it is just to a link, like a fast link to where your stuff is stored. So it almost acts, yeah, it just kind of is acts like a um, you can load a project and it'll just load you right to that folder. And so how we do that, I don't think we've done that. I know we haven't done that yet in class. So I'm going to show you how I'm going to build an IPJ folder or file here, I guess. And so right here, we've never messed with this drop-down box, which just says default right now. We've been running it just in default mode, which gives you access to all the default libraries, the default stuff that came in when this program was downloaded. So if I expand this, or maybe I got to go to the little arrows here. Yeah. Right now, it'll let me switch to Inventor Electrical Project. I think that's also been preloaded. If I just expand this and go to the settings, it brings up this dialog box, which just shows like these are projects essentially. So I can load a project right here. And it's an IPJ file to look like this in your little folder structure. It has its own little unique icon. But I'm just going to say I want a new one here. So if I say new, it's going to want me to say, is this a new single user project or a new Vault project? So this is also if I was working in a company where they had Vault, which is just a library system, right? You have to check things in, check it out to make changes. We're not doing that. I don't have Vault set up. Canvas kind of works like a Vault in some ways, actually, but I'm doing a new single use project. So I'll say next. I think it should just give me, um, I can give it a project name and place where this is. So I think I can give this thing a name like Screw Conveyor. I'm going to give mine just a little bit more of an official title, my 1138 Screw Conveyor. This is my project name. You could, whatever you're working on, if I spell it right. Screw Conveyor. Maybe I'll say 2026 for me just because I'm starting from scratch here again. I should pick a path, and what I'm looking for is that folder system that I just barely built. So I'm going to go here and search that out real quick. It should open up a browser where I'm going to find my drive, find my class that I put this in for me. There it is. And then there's my screw conveyor. And I think I'm just going to pick, yeah, did I do? Oh yeah, I want to pick, this is my actually new one that I made. Here's all my new little folders I made. So I'm gonna pick this main folder where my other little subfolders live, the assemblies drawings. I'm gonna say this is the main folder all I'm gonna do is this is gonna create a point that I can drive to this folder like really fast and not have to always go searching for where to save stuff or where to find stuff when I'm in Inventor. So I'm gonna say okay on this. That's where I want my link to kind of be. And then this is going to create me a file on that drive. It's going to be named that. Okay, so I'm going to say finish on that. And it should populate up here. Now I've got like three different options. The checked marked one, if I click over here, or maybe I have to double click them. Yeah, just double click them to change from one project to the other. And so now this will just act as a link to get to that file really quick within just this menu right here in Inventor. And so I don't have to like always be searching and searching through all my files, which is really handy when you're working in an environment where you get on their server and you're like, holy crap, it's like 15 layers deep that I'm saving stuff and easy to get lost in companies' folder and file structures. So here's just a way to create a link to right where you want to be working. Um, and what it allows you to do down here, which I'm not going to make too many changes because I really don't have any libraries or whatever, but you'll also be able to link to other folders. And so if there was a different location where libraries were stored for the company, I could link a library folder here. That's the one thing that we would mainly do when I worked for a company where we used this process. Sometimes I'd have to go through in every project, I would like link the libraries and link to some other folders that I was going to pull parts from, mostly a library, sometimes a content center, materials that were used or yeah. So I'm not going to really add anything here, but this is really where this is also further, customizable to add like quick links from your project to other folders that are on a server essentially. And if I say done on this now, um, and I just made sure before I said done that I was in that project. And so when I go to open now, it should drive me to that folder structure here. So now it's just going to be a quick link to that. And then I'll just take a look at, so I'm going to cancel this for a minute. If I look through it through my file browser, I should see that little IPJ. So if I was somewhere on a folder, and if I was digging through companies folder structures with Inventor, um, and I went to my place, I should see that little icon show up that there's essentially an Inventor project file link. So that's kind of handy, especially when you're working on stuff that's easy to get lost in when you get a lot of files. So there's mine. There's my little IPJ file. I don't know if you can really open from here. I don't know. Probably, yeah. If you were just coming in and you didn't have Inventor open, I think it'll like open Inventor and like load that project. But so there's my little project file. Be quick to easy, save stuff and find stuff, not have to dig through so many files. So that's one setup. Now I feel like I'm kind of set up to build. And now I just got to know how to build this thing. So I'm going to review my spec sheet here. This is the not the SEMA standard, but this is my design requirements from engineering. And so really what I want to look at here is I'm not going to go too deep into the sizing of this. I've tried to size it so it would be realistic. Like it's got 9,000 to 12,000 pounds of potato an hour running through my conveyor to transfer. What I'm saying is from a brush machine, which I haven't pulled up any imagery for what a brush machine is. I kind of talked about it, but um, yeah, yeah, just throw them in there and let them tumble through this thing. Yeah, it's essentially just a potato dishwasher, potato washer. And yeah, there's all kinds of let's see. I was gonna look for some images of what my one might be. The essentially thing is potatoes get washed about quite a few times. They get sorted before they ever get processed. They're going to be washed, sorted, stored, and then when they're brought up to actually go to the process line, they'll usually be even brushed again um, before they're ready. But yeah, I'll look for some imagery. And like I said, I was going to set up a Navisworks just kind of platform where I have a couple pieces of equipment, at least the block of what the equipment looks like. But yeah, I'll come back to that when I find something that is what I'm looking for. But all we are doing is the brush machine is kind of scrubbed the potatoes one last time before they're ready for processing. They're going to be scrubbed and then actually just dumped into a pump tank and then pumped to a different location in a plant is what's going to happen here. So that's kind of how I've envisioned this project. For one, it's just in a conveyor that's going to transfer from one piece of equipment to the other. Um, so they're telling me that they want me to build a 10-inch screw diameter, and they're just saying it's based from a 9-inch screw size because I think you'll find in the SEMA standards maybe they jump from 9 to 11. So I'm kind of saying, well, um, if I've sized it so my load will fit in um, a 9-inch diameter screw or auger, which is kind of the flights or the overall width of an auger. They're saying, well, if we build a 10-inch one, it's just a little bit bigger. It'll handle what we've sized for 9-inch easily or easily. So it's kind of like they're already having me upsize a little bit. And the only reason for that is because I've got data that I can work with in that SEMA standard. Maybe when they based the engineering data off it, it was they were looking at the 9-inch size. But that's kind of an oddball size. And maybe in my company, we build 10 inches, 8 inches, 12 inches, some kind of even size system of screws. And so even if it would work in a 9-inch screw, it's like, oh, I'm going to build parts for a 10-inch screw, which is maybe more widely usable for other types of products as well. So that's kind of my thought here. It does want us to span 8 feet from where the potatoes come in to the discharge. And so let's see. We've got an even flow hopper to worry about, and we'll come back to that later. I'm going to work on the housing first. So this isn't something I have to worry about right away. And then eventually, when I'm starting to assemble stuff in my assembly, I'm gonna go in and pull these McMaster card links for these particular. I'll pull the step files and convert them into an inventor file. We've only done that one time when we did our little V-twin piston project and pulled some McMaster car parts in as step files, and then had inventor convert them to an inventor file. So we'll do that again, and then we'll have to have this. We'll have to go through um, and figure out the drive and gearbox too later. We've got some work to do before I've got to worry about that. And the reality is, though, a drive and a gearbox is a pretty what we'd call like a long lead item. And so the sooner you size your conveyor, and this happens in a lot of design times. And I'm entering the design world here more than a drafter world for sure, right? So we're at week 8, or yeah, we're at week 9 in the last semester. So we're putting on our designer hats a little bit. So sometimes designers have to worry about when they're given a job to do. Sometimes I've got to worry about ordering parts as soon as I can because sometimes lead times can be kind of long, and so the sooner you can get things sized accordingly and then get things ordered, then they're ready for manufacturing when they're ready to assemble, right? So sometimes there's a little bit more planning ahead on the design stage to make sure you've ordered your parts. Of course, you have to be really careful ordering early parts because you got to make sure they're right. I'm not going to worry about that yet. We'll be able to put it off till we're ready just to put them go because we actually don't have to order one. We just need this step file from their website. So engineering has used all of this to kind of like classify how whole potatoes are. And so this is this is just from our engineering. Maybe they have a document where they go through and they say, oh, this is, so, some companies, once they are designing equipment that they're using over and over again, they probably have some library resources where this is what we used last time. We're going to use this again. We've already classified what whole potatoes are long ago, so we already know some of the things you'd have to know, which is how lumpy it is, how it flows, how abrasive it is, any special characteristics they're considering. They classify that material type into like this component group, and they say, well, I don't want like I'm going to do a trough loading type, which is kind of like a U-shaped trough loading screw conveyor. And they're saying I can only really load that with my product 30 to 45% full. You got to have quite a bit of like airspace in an auger. I mean, augers can run 100% full. It takes a different design to do that. And it definitely takes some more horsepower and torque of your gearbox and motor, and everything has to be designed. If you're going to load a screw conveyor really full, it's definitely not recommended for most applications, but there are some times when they will do that. So they would consider, okay, this is how much we want to load our trough. I've got a few different types that I could build here. Uh, the engineering has to be concerned with like what the bulk density of that material is, and that's just how tightly this product is going to pack together as it gets like dumped into a screw conveyor, and then it gets it gets kind of squished between the auger flights as this thing twists and turns and moves it along and then discharges it out. So there's some packing going on with what we call like a bulk density in like a cubic. It'd be like a volume that I'm looking at here. This is volumetric bulk density of this particular product. 40 to 50 pounds per square feet is what whole potato will pack into, I think. Then they come out with a material factor. All these little numbers that I've highlighted kind of show up on that SEMA standard on this next spec sheet that I'm going to go over to. But we're going to use 304 stainless steel for ours. Pretty common in food plants. It will be a stainless steel um, application. Sometimes they get away with not having that early on in the food processing, like when the product actually comes in into a food processing plant. Sometimes some of that equipment in what we'd see as like truck unloading area where trucks are coming in and dumping their product, not just potatoes, but other products. That can be kind of sometimes that's carbon steel or there are some applications where it's not all stainless steel in plants, but more and more it's becoming more common to make even that stuff, truck unloading areas, stainless steel, just because they don't want contamination in their product. But okay, and then technically, yes, it's telling me you will need like, and I don't have this on mine yet, but we might need some switches that we can go to a manufacturer's website and pull some safety features into my design at the end, so that so the doors, if they were happen to open up, the equipment would shut down, right? Nobody wants to get their foot or arm caught in an auger. You're not gonna, those generally lose appendages when that happens. There's a lot of torque on these gearboxes, so we've got to really consider safety at the end. Make sure there's no points where people could fall into this, or if they did open a door, it's got to shut down the equipment. But that can come in at the end too. I haven't picked out specific sensors yet, but we'll get to that. That's kind of that's like the finishing touches on designs. Sometimes I need to incorporate the sensor brackets into my design and how to hold the sensors and modify my parts that are going to be where the sensors go. So there might be a little bit of touch and go work at the end there to get a sensor put on. But so that is what this is. This is just kind of like pretty typical what you would get looking at engineering and sales and what they're visualizing this concept is going to be. For me, then I can go to start working on this as long as I get familiar with what the SEMA standards are. So let me bounce over to this one where I had that image of this. So we want to do the housing first. We're going to do a U-shaped housing, similar to what that part E is here. So I'm just going to go through here and see what bunch of applications. Yes. But this is pretty interesting reading stuff. There's all kinds of different ways you can build it. Ours will not need a coupling shaft in it. Mine is short enough, 8 foot long. I won't have to have what they call as a carrier bearing. So for really long screw conveyors, they can't be like just one piece, or else they'll sag and drag and rub against their housings on the inside. And so we can they have systems where you can hold screws up intermittently along a really long screw conveyor, and so that it doesn't sag. Hanger bearings. They hang from above, and so they actually just kind of loop, like if I like this one right here is like how it would hang. So technically your product, if it's only 20 to 30% full, you're below the center pipe, right? Like our center pipe is the one that's running down through and hold the big long pipe through here is what I call center pipe. And generally if we're only loading 20 to 30%, we're going to be like 50% would probably be up to the center pipe halfway in my housing. And so yeah, generally these aren't in the way of actually the product, unless you're running a fully loaded conveyor, you know. And then in that case, it won't really damage them. They'll just take a bit of a beating. It'll be harder on those bearings to do that, but you'll find a lot of food processors try not to do hanger bearings. They're just kind of a dirty little thing that are hard to clean. And so if they can avoid it, they'll even stretch the bounds of how far to run without a carrier bearing, even if they have to like make the housing a little bit bigger to allow the sag. They sometimes will do that. Yeah, that's a good question. So this one shows kind of the trough ends. I'm gonna do a real similar design to this. So it just has you some descriptions on what's going on here. I know the photos look like they're from the 70s, but yeah, this document's still available online. Um, Different screws. Okay, there's some welders doing their thing. Gets into the design data where this is kind of where an engineer may have gone through this pretty carefully to determine what the product, what the bulk densities are, and and those classifications of materials. So they would have gone through this pretty carefully, and you can dig through this too. Not that you're going to have to do anything with it, but it's just kind of interesting information on the on what we're considering when we're sizing a conveyor. So all of this goes down, gives you some ideas on how big of lump sizes it can handle, and even starts to show you like even what some of the materials are going to be made out of. I don't know. I'm in here where we're in like we're in a 10-inch range, somewhere in between here. So I know that I'm going to make my housing, and I think there's a better description down below out of 12 gauge because I haven't highlighted anything in here yet. So, but there are some kind of redundant charts in here a little bit. They give you some idea of what the sizes of your stuff is going to be. Eventually it gets into this material table where this is where bulk densities and kind of how they categorize materials. Uh, Here's the cubic weight per foot. Yeah. And so the funny thing is, this is a common one, and they have common materials on here. They don't have whole potato. They have like potato flour, I think is the only thing. So I just had to go to an outside resource where there was somebody had categorized bulk just whole potato and its density and its categorization. And so yeah, these are all just different materials and how they categorize them. Then it gets into the capacity charts. So what happened was I think I went in here and marked up the ones that apply to us. So let me scroll down a little bit and see if there are a couple marks. Horizontal screw conveyor. That's what we're doing is a horizontal screw conveyor. Let's make sure I marked the right one. Oh yeah. You have to be worried about the way your flights go. Like screw conveyors can be what we call right hand or left hand, which is it's the way the flights around that center pipe twist. And it also impacts the way that I drive it. So this is like if you ever get into screw conveyor design, this little image is like super important. Knowing if you have a right hand conveyor and you're twisting it, depending on which end you're standing on, right? Depending on which end is your drive end, uh, it has to twist the right way to either pull or push product. I'm going to build right hands are more common. Like it's usually like if you don't specify, it's going to be a right hand conveyor is definitely most common. But there are reasons why I might need a left hand one. We're going to build a right hand one with no hangers, and we're going to put our gearbox on the discharge end. And I think there's some reading in here that says that's kind of potentially where you would do this, but there are reasons why I would put it on the inlet end. So if I have ends of a conveyor, I think of it like an inlet end where product is coming into it and a discharge end where product is exiting the conveyor. And so you can put your drive on either end. You just be essentially pushing the product through the housing or pulling it through. And I think if you did a quick Google search, I think I even checked this not too long ago. It was like, yeah, they would probably tell you to pull it through. So put your drive at your discharge end. It's maybe, but it will still work from the other end. And there would be a reason why in some cases I might do that. So, um, or there might be no reason. They just did it that way and it works. And so they continue doing that. But let me see where we get into some. So finally, I get into something that I've marked up here. Looks like we've got a breakdown here of a lot of different potential variables here. And I need a conveyor that is 10 inches. So I'm clear down to whatever sheet this is, 17 of 41 here, before I finally get into something that I've actually marked up. That I know engineering wants me to do a 10-inch one. So I've marked that. The coupling, the shaft and the coupling diameter. So this is going to be the shaft that I'm going to get bearings for. So where the bearings are going to load out here on the outside of my conveyor. It's going to be 2 inches there, a 2-inch shaft. It looks like what they're telling me maybe is how long I can build this. So I don't know if I need all of these marks that I've done because A is what total trough. Well, I don't know which one A is. A is standard conveyor screw length, but we've got a bunch of different A's here. 9 foot 10. B, what is B on this particular? Okay. It's been a bit since I've looked at these super carefully, but B, oh, bearing center. So if I did need hanger bearings on a long, I would at least, so if I've got a really long conveyor to make, this manual is telling me every 9 foot 10, I'm going to probably have to use a carrier bearing to hold up the auger in the housing. And so mine is actually 8 foot, so I'm not going to need a carrier bearing. So I'm not going to need too much information here. What is C? C is, oh, I don't know. I don't know where my variable C here is, kind of confusing, but CL, C, what is the dimension? C is 2 inch. Oh, so it's got to be something about the shaft size. Hmm. Yeah, what is, because I don't know what L is either. But yeah, you could be, that could be, I don't know what's going on. It looks like I kind of quit marking here because I was like, maybe this is, and what's E? E. Oh, E is the inside of of my housing, kind of is 11 inches. Okay, so I've at least got, so I've got this like thought that it's a 10 inch, it's going to be 8 foot long. I'm not going to need any carrier bearings. The inside of the housing is probably going to be 11 inches wide. I think that there is some better imagery as I scroll down. Maybe this is just the quick, a quick like first look at my some of my design considerations here. Let me scroll down a little bit. This would be a chain drive. Yeah, you guys have learned about chain drives and gearing. So this would be a screw conveyor that comes through. They hook a sprocket on and put a chain to a motor here and drive this thing. We're going to do a shaft mount gearbox, which is just kind of a little bit cleaner. We don't have all this guarding necessary, and we don't have the a chain. Chains are kind of dirty in the food processing industry. They still use them in areas, but they like shaft mount gearbox have been all the rage for quite a few years in food processing because they're just little cleaner assemblies on the end of your conveyor. So I'm not going to do a chain drive one, but they give you some chain drive considerations here. Helicoid. So now we're talking about the kinds of flights that are on this, and I think it's funny they jump right into this. I think they show some imagery somewhere. Yeah, maybe ours is going to be like a helicoid type of screw. Just I haven't marked anything up there yet. Sectional flight conveyor screws. I did mark 10 there. Thickness or gauge of flights is 10 gauge. Standard pipe size, standard weight, 2 inch pipe size. Yeah, I'm kind of scrolling through this because I haven't looked through this for a bit. I didn't look through it since the start of this week to get super familiar. I knew I'd marked it up last semester, but lights for sectional conveyor screws. There's 10-inch pitch. We'll talk about that. A pitch is just going to be kind of like on a like I can look at the size of a side of a screw here, and I can say, oh, it's kind of like a fastener threads, right? And so pitch on a screw is really from flight to flight to flight to flight. So it's kind of like pitch on a fastener, actually, on a screw thread, just from peak to peak or valley to valley. It says here we need 10 inch. That's what we call like a full pitch. It's pretty common in screw conveyors to say, what is your screw diameter? Ours is going to be a 10 inch and so you would match the pitch would match the diameter and that would be considered full pitch. You can do double pitch and you can do half pitches and you can do there's reasons why sometimes in vertical conveyors where I have to actually like gain elevation and go from low to high with my conveyor like an inclined conveyor. Those pitches will be less than a full pitch. They kind of you're trying to prevent like rollback of material. So ours is just horizontal, so we'll be at full pitch. I swear I marked up this thing a little bit more, but maybe it's just down further. Different, like a different, what is this one called? A ribbon conveyor screw. We don't have to do a ribbon screw, but here is one. There's a double flight, double pitch. Oh yeah, here's where they talk about a few different, the reasons why I might use um, different shaped flights and increase or decrease their pitch. So this is interesting. Now we get into just the screw itself and some of the dimensions around that screw. Yeah. So then we get into some of the hardware that I need to use. If I've got to couple them together, okay. Drive end and end shafts. Looks like I've done some markups here. Some of this stuff applies to what I'm going to need to when I get here on the drive and driven end shafts here. So it's not going to really affect my housing. This is definitely going to affect the screw first. I'm kind of scrolling down through it and looking to see if there was more stuff on the housing. Here's some bearing information that I've marked up. Of course, we don't need bearings yet. We don't have even a screw to hold up in a housing yet. Trough ends. Okay, so maybe now it's down here. It's funny. Yeah, now we're starting to get into the ends of the trough. Looks like I've done a little more markup here. Trough ends. Maybe I'm doing one of each style. I'll have to see. I think I am. Yeah, I think we do one of each style. Some more bearing consideration. Dust seals, or what we call seal plates. We did one of those in AutoCAD. We'll have to build another seal plate for this one. What do we got here? Roller end bearings. So this is going to be end bearings, thrust loading, bearings that are able to handle thrust. Which, when you're conveying, through a screw conveyor, and we dump product in it, and the gearbox is twisting the auger one way, and the material is moving the other way, then the thrust is going to be opposite the way your material is moving. It's kind of like these forces that are opposing each other. As I push the product through, I have like a thrust going the other way. If that doesn't make sense, we can look at it. I think we can automate our screw conveyor at the end and watch how it turns. I think we can build some product and dump in it too. So here's a housing. Finally, so it's funny. I would have thought they would have started with housing, but they actually start with, I don't know, everything else besides the housing. It's towards the end. I'm looking for I was just kind of scrolling through till I find some housing stuff. Double flange trough. So I got these two flanges. You've been learning about flanges in chapter 19. And we did a project where we bent some flanges out of sheet metal, but we're going to do a lot more. So yeah, we start to see some this is a better schematic than that one that was way above that had the whole screw. This is definitely going to help me size my trough for a 10-inch diameter uh auger. Everything's kind of based on the auger, like outside diameter of those flights. And so this should obviously, like, A for a 10-inch should be bigger than we can kind of see how much clearance I would have. So yeah, here's my center of my screw in here. And it's going to be like when we say 10-inch, a 10-inch screw conveyor, we mean how big the flights are inside their diameter. So if I'm 10-inch, how wide is A? That's how much clearance I'm going to have essentially around so A is what? A is 11 inches. So essentially it's 1 inch bigger than my screw, and which means I've got a half inch of clearance between my screw diameter and the housing here. So that's how I think that's a pretty standard clearance. Some places for fine product will push that down lower. For whole potato, that's fine. Our whole potatoes are generally bigger than a half inch, so they're never going to like slide in or get cut by the flights. But we do have to consider sometimes if materials are small, they can get cut by the flights, like French fries if they've already been cut, and I put them in a screw conveyor, and I don't have maybe I need a tighter tolerance sometimes than just the SEMA standard half inch. Otherwise, you're going to cut your fries up by your screw. And you would think that it like traps material in there, but it really doesn't. That's like the pile kind of pushes the pile through. You might get some stuff that sticks to the inside of the housing, but eventually they wash that out at some point. But um, for the most part, the pile will kind of push the pile through. Okay, so I'm going to need this one. This is going to be one of my most helpful to start, I think. This is going to be the covers. Once I get a housing, maybe I can consider what to cover, how to cover it. You know, in a lot of industries, just a simple like flat cover works. In food processing, they don't love that because it can just collect, especially on a horizontal screw where it's just like generally, is level across wherever it's running. You'll just pile up dirt and contaminant over time. They can just, fall from somewhere and land on top of your lid and just stay there stagnant and gross. So they tech and even it can pool up water and sit on there or chemical or whatever. And so like in food processing, we like these little hip roof designs where we're allowing water and stuff or other particulate to kind of shed off, especially as I spray it off and clean it. It's pretty common in food processing plants that even while the line's running, I might do operators can do like an external clean of their area and really not get stuff in the product. And then if you do need to load a conveyor like beyond 75%, they do this kind of a design where you almost like force the material to stay in the screw. And so this kind of lid actually almost then surrounds the actual auger. And then you're able to load those things up more than 30 or 40%. Maybe I can load this 75, 80, 90%, as long as I've designed the actual screw to take all that torque, and I'm driving it because it's almost like you're kind of under pressure a little bit there by really. And where you'll see this is on vertical augers sometimes if they've had rollback happen, like if it's a pretty steep incline auger and they are going to maybe worry about product rolling back on itself as it's trying to auger up and you've got a really full auger, they can prevent that by having a shroud type lid over it and force the product not to roll back. Anyway, that's kind of interesting. So then I've got some supporting feet, and I think we'll build like I think I mentioned it's going to be like 8 or 9 feet, 10 feet up in the air. So I'll have to build a little support structure for it and a place on my conveyor to mount that structure to. We've got some flanges to consider, feed and discharge spouts. Yeah, so here's some dimensioning for just kind of standard dimensioning for how I would want to bolt on discharge and inlet. So on my discharge and on my inlet of my conveyor, how I'm going to attach other equipment to it. So they kind of have a breakdown of that. So really this whole document just kind of, it doesn't make you have to like, you're not really redesigning much. You're just trying to follow their standards here and figure out where yours fits. So let's take a look. So I'll probably have to jump around this document quite a bit. I just want to take a kind of a slow peruse through here. And I want to go back to the housing one. That's what I really want to build. I know I've got like this 8 foot long conveyor. It's going to be 10 inches. So how do I need to draw this housing? And so what we're going to do is start doing some drawing now. Probably with this sheet being my starter sheet potentially. And so what I want to do is kind of build a housing like this, a solid model. 8 foot. I think I built mine 8 foot from, I wonder if it's center of my, I think when I would see this, I would think of its center of discharge to kind of center of inlet. Let me double check mine really quick and see if that's what I did, because I think that's kind of what I would think. I'm going to go back one here to my one that I've already built real quick. Let me open this one up and I'm just going to pull a quick dimension. This is telling me I'm not in the path that I've actually established it's not in my project path because I'm in a different folder here. So you might get that little warning if you're pulling parts that are stored somewhere else. But yeah, I just want to take a quick measurement from, I don't know, from what is mine overall here? Let's just go from end to end. I think I did. Okay, so I didn't go from center to center. I just went that mine is 8 foot overall from end plate to end plate. So let's stick with that. That'll be a little easier. So here I am on my home. I'm going to open up a new standard part. This is all going to be in inches. So I'm not going to open one that I have. I'm going to open up a new one, just make sure I'm in English folder and a standard part here. Let's create this thing. So I might consider how this is going to end up on my sheet. My front view would probably be looking right at like if I think of the screw conveyors, my front view is probably going to be like this. This is probably going to be my side view on most of my sheets. So I'm already going to kind of plan my housing that way, but this is going to be front, or this could be front, but I'm going to definitely build this so my housing is going to be like this in my right side view. So if I come over here, and I'm going to have this little SEMA standard sheet, specifically this sheet. I'm on sheet 33 of this thing. Maybe I'll zoom in or zoom out just a little bit. I'm going to start kind of I'm going to build a solid is what I'm going to build. I'm not necessarily going to build it like with its thickness associated. I'm just going to build it with these dimensions kind of in mind, but I do have to think about what the materials are a little bit, I guess. So what I do need to identify is a little bit about like I'm going to build a solid, but I'm going to build parts from this solid. And so I'm going to kind of need to know like and this is going to be sheet metal. So I need to know like what is the thickness of sheet metal that this is going to end up becoming, because it might factor into some of my dimensioning of how I build this solid. Because like I said, I'm not actually building the sheet metal part now. I'm going to build something that I could kind of extract the sheet metal part from. And so how this works is I just need to find out what that material is. And I think up top, I didn't have it marked, but it said it was going to be 12 gauge. And I'll see if I can find that out again. For sure, this is the sheet I'm going to come back to for the dimensions of what the front view dimensions would kind of look like. So I'm going to put my thumb there for a minute, and then I just need to know where did they talk about sizing it for materials? It wasn't in any of this. This one has some material sizes, but it's actually for the end plates, which are going to they're kind of a little bit more structural on the end plates to kind of hold the form. And so they're going to be a little bit heavier materials. The bearings, I'm not evaluating the screw yet. Just looking for housing information here. So there's all the screw flight information, right? So I think there was a little bit of information. Maybe it is clear back up top here on the material that I want to use for my housing. So those are all flights. Those are all flight screws, lots of stuff on screws. A typical drive assembly. There's that one that I paused on for just a minute. I don't think it had materials. It just kind of had my length and if I need a carrier bearing or not, and I don't. This is going to be critical a little bit later when I do my screw. So maybe it is, and then this is my trough loading. I thought I marked one here though. I have to look at, it's not different in your guys's, is it? Hopefully not. I was pretty sure I marked one of those there. I hope I don't have multiple copies of this floating around. This might be the best area that talks about material size for the housing. Just go through real quick. And none of this was all just information on what my parts are. And that's the only, I was thinking there was a better one that showed me material for housing. The only one I'm really seeing that's material is on this sheet. This is on page 11. After I pick my size, it gives me my materials. I'm gonna do one little double check of my resources here. Make sure that is my abridged one. It should be the same one that's on your guys' folder. I didn't open this from here, but let me just double check this one. Might take a minute to load. See, it takes a little while for the ball to get rolling here. I told you. I think this is the same one that I've uploaded though. Never marked that. I'm surprised I never marked that chart. So I'm surprised. I thought I marked one that was right there too. Yeah, that's the first one I start marking. Let me look one more. Give me just 1 second here. I think how ours is 41 pages. I've pulled out a lot of other sheets. The original why I call it abridged is because I pulled out some of what I felt was some definitely unnecessary data. Let's just make sure this is my unabridged version of that same manual. I just want to make sure I wasn't marking that somewhere else. Yeah, I think there was some more complicated screws I wasn't going to consider at all, so I didn't want them in there. I pulled out like 20 pages or so. Just want to make sure I didn't pull out some housing page. Oh, and all the hanger bearing stuff I pulled out because we didn't need one. But I think other than that, it's the same manual because this is the sheet I have. Yeah, yeah, okay. Oh, maybe I'm being a little bit too hasty. It looks like it does have the trough thickness on that sheet. So cool. So I can go back to my, okay. I don't need this one up here. This is good information and it really it's probably the same information, but I'm going to go back to that one. What did I say? It was page, I get these kind of where I kind of memorize just the location of them, but it was page down here, right there. This is going to be my main page for today. This one. Yeah, yeah. Sorry, I should have just looked at my markings. 12 gauge right there. Okay. So this is the only sheet I need today. I am ready to draw this. 10-inch is made out of 12 gauge. They have a code. If you wanted to order it from them, this would be their maybe a product code here if you needed to replace a housing that they had supplied for you. 5 foot, 10 foot. Dimension A is the ID of my housing. It's 11 inches. Dimension B is kind of that flange width. And if I like zoom in on this, kind of hard to see, but I'll zoom in a little bit. You can see this is what I would call the outside diameter of kind of these flanges going. So B, they're giving me this kind of outside diameter, not the inside of this. So those matter because I have to consider how thick my steel is here to get that dimension. But they're saying that B is 1 13/16. And then C is overall, once I've done those bends, I need to end up with 14 5/8. And then what's size D? D is down, this is kind of the U shape of the trough rather than just being a cylindrical screw. We're going to go up this 6 3/8 from kind of the center of where the screw is. Oh, how I would start this with it being 8 foot end to end. So what I'm going to do is I'm going to come in here and I'm going to build a solid that fits inside this thing. Is how I'm going to start this. So I'm just going to build this kind of like if I filled this thing full of water, what it would look like. I tend to make my solids blue just for some reason, just so they kind of stand out. And the last thing I want to show you is that I did kind of develop a numbering system. We're going to build a lot of parts. We're going to build some assemblies. And so there's one more little resource here on your, I'm going to go close that PDF because I'm tapping it out where we are. I've uploaded the sheet metal gauge chart so we know how thick sheet metal is because we don't have that memorized for sure. And I've got this drive motor calculation sheet, which will help me size my motor, but I've also got in there, I added one more little thing to this. So I'm going to open up this little Excel file. And if I had to scroll over, let me zoom out a little bit. Yeah. This is what I've just developed for a numbering system. So this is how I want you to number your parts, which would, if you work for a company, they're going to have a numbering system for sure. And they may have a macro built into Inventor that actually just, when you open a part, it's going to make you name a part to their standards. So I've seen companies where they already have built, they've programmed their program so that anytime you're going to save a part, it's going to be requesting you to save it in their schematic or their little coding scheme that they've developed. Most companies have a systematic approach to how they number and organize stuff. So I just kind of developed one last minute, and I thought, oh, I want to say my numbering system is going to be, there's going to be a prefix, going to be ISU dash, that's going to be your drafter initials. So I have just ISU dash edu, but you would just do ISU dash your just two of your initials. That'll make your parts unique. And then sometimes I have issues opening parts when everybody's named them the same. I have to usually like delete them from my download folder and then read. Anyway, so if you put your initials in your coding system, that'll keep yours unique to you. And then we have kind of what if I was an equipment manufacturer and I built several different types of equipment, maybe I would have a coding system that would be easy recognizable once I knew the system that I could see, oh, SC is a screw conveyor. So if I was looking through a bunch of like library parts and I see SC, I would know all of those parts are from a screw conveyor. In my mind, in my imaginary world, I'm like, we also build brush machines. That would be a BR code. We build pump tanks. That's a PT code. We build steam peelers. We build blanchers. We build cookers. So I've just developed a fake coding system. But that would be one way to say, oh, that's because I can't really recognize parts necessarily from just a number, which is why when you go into Inventor and you're like perusing through parts, it's nice to have that little quick view of a part so I can just kind of click through some files and decide, oh yeah, I have an image that populates with that when I'm clicking and I'm opening my parts through Inventor. It's a quick way to see it, but I also can filter out what I don't need if it doesn't have the right code. So I'm going to code mine to be like ISU. So when I build mine, it'll be like ISU-MR-SC001 will be the first part I build. If I'm on my 10th part, it'll be SC010. And if I'm the only thing I've added as a caveat to that is if I'm building a solid, which is really never going to live in my prints, it's really what I'm designing from. It's kind of like a part model. It's going to be like a base component is what Inventor considers what I'm gonna draw today as a base component. And so when I'm building a base component, I'm gonna do a dash S at the end of that. And that's just because it's like a solid or it's like a yeah, it's not a part, it's like what I've built my parts from. And so it's a base component. So we're building a base component. So I'm going to have a dash S when I name this part. So if I'm going to go into, so that's what I'm going to start with right away. And then I might, as a drafter, just have to keep track of what's my next part number in my next sequence. And I'm just going to keep that numbering system going along. It's just going to be 1, 2, 3, 4, 5. Anytime I build a new part, I just want to remember what the last part I built was and name it the next one after that. If people build macros and you're working from a company that has an auto-populating one, generally it's already going to auto-populate the next number for you automatically. Here, I'm going to have to keep track of it a little bit myself, just so I don't get the same part number. Although even if you're in that folder and you're trying to save it as the same part number, you're going to get that you need to name it as a unique file name. So it's not the end of the world. If you forget which number you're on and you try to name it the same number, it's going to give you a prompt that says you can't say name it that. If you're in an assembly or whatever folder, it'll let you name that thing the same. So just got to make sure you're in the right folder. So I'm going to come in here and say this is a solid. So I'm just going to go ahead and do a quick save as right now. Save as, and I'm going to show you how my numbering sequence. This is going to be a part. So I'll go ahead and throw it in my parts folder. And of course I have my IPJ, so it already drove me right down to where I want to save stuff. So that's kind of quick and easy. That's the whole point of that. And then I'm in here saying, oh, my first part is ISU dash for me is MR dash SC for screw conveyor and 001 because it's the first one I'm going to build. And then it's a dash S because it's a base component or a solid parse, what I would say. So it's in my parts folder where my real parts will be as well, but this is where their solid will live for this. And then I just want to make that U shape, kind of what the volume would be that would fit in this. So I'm just going to stay in generic type of material here. And I'm going to draw on the front view. Sure, let's draw on the front view plane. I'm going to start a sketch. This is my front view plane, right? XY. So I'm going to draw this from the profile, kind of what that looked like on that on this sheet here, right? I'm kind of drawing this, but I'm not drawing all of this yet. I might just draw this particular shape from kind of the D dimension all the way down, just kind of this U shape, what would fit inside of it. So let's do that. So it's just kind of a U shape. So I'm just going to go, it's going to be kind of big, but I don't have to draw it at scale necessarily. I'm going to enter these. I'm just going to draw mine out the shape it is, which I'm going to say it's like a U trough like this. I'm going to use my little swoop-de-doop. It's at halfway here. And then I want it to come up to there, right? Like that. And then I want it to close off. I'm on the XY plane front because I am planning on, my right side is going to be the extrusion that I'm going to do. And it's going to be like the side view of my screw. So, oh yeah, it's super weird, huh? It's just that when you're in a line command and you're drawing a line, I would like left click, but then I left click again and I hold left click and then I just sweep and I pull it. I'm actually holding the left button down when I do that. Yeah. And then I kind of like look for that I just look for those projection lines to show up like that. I'm looking for it to be a full semicircle there, half circle. And then I just let go of my left click button and it'll establish that. And then I'm gonna use that object snap tracking like that. Yeah. It's a good one to get. It's a good one to get. It works great for this application. Yeah, it takes a little bit of practice. It's like, here's my line. I've left clicked the endpoint of this line. Now and then I left click again and hold. And then I just wings for you. Yeah, you could go this way, you could go that way. I think you could do more than a full semicircle, but I'm looking for those, yeah, like that. Yeah, it's a good little hack trick. You could also just draw a circle and put sides on it, right? But you can't actually do that. Yeah. I think it takes a little practice, but and we don't use it a lot, but I just want to constrain this thing though. I'm going to constrain on my origin point. Yeah, you keep trying? Sorry, yeah, do it. Help is on the way. Hey, that is a You just sang a Grateful Dead lyric and you didn't know it. Did it work? Yeah. Thank you, Lydia. That is a handy little thing because you'll find you use that all the time in a shape. I'm going to constrain the center of this. I want this center point on my origin point. I think that's going to be where I'm going to. That's going to be where the center pipe runs through this thing. I haven't even sized this yet, but I'm going to move it in. I'm just going to move it into this location here where the center of this is on the origin point. Now I'm going to start dimensioning it out here. And so it's 11 inches wide. That's one dimension I know. 11 inches. That's the inside diameter of my housing. And then this what is this dimension? Oh, that's going to constrain this for me, obviously, because that's the same dimension, same diameter down there, which is what I want. I just need the overall height, and that sheet gave it to me right here, right? Like D. So I've just got this little shape, and I just need to add in this D dimension, which was like 6 3/8 right here, right? Six and 3/8. Yeah. So I'm going to say dimension this thing. Yeah, exactly. 6.375. I was gonna, it's funny that you just said that because I was gonna upload to our resources for this a decimal equivalent chart because that's always handy to have. And that's all it took to constrain that thing. What I love about those dimensions are they go right with my right with what I pulled where I pulled them from my resource. So now I'm gonna extrude this thing 8 foot long. Yes, let's do it. Extrude that thing. And I'll probably do this. I'll probably do this over center line, like I normally would. I'm gonna keep my shape centered over the origin plane, and so I think I'm gonna do this. And 8 foot is 96 inches. I think you can put in 8 foot too. I don't. Well, I don't know. And then I just turn this to some color. I don't care what color you turn it to. Like I think I've used like some blue. I don't know what, not that blue. I've used some, but whatever color. Like the only thing is I like this as a visual because it's really not going to be a part. It's just going to be a base component. So just some color that you're happy with. And I keep all my solids the same color so I can identify. What's that? Satin blue? Oh, it is. Yeah. This is a good, there's a clear blue. That's a little too clear. But just come up with some color, and I don't have that satin. It's in the S's, or is it? Yeah. Oh, sky dark blue. I don't know. And you don't have to choose blue. If you hate blue, don't choose blue, by the way. You can choose whatever color you want. That is true. I just it's kind of like I'm looking at the volume of that conveyor, and that's what that would be. And now I just want to start building out. What I'll show you is I'll drive down to kind of where I'm getting here. So this is my part, and I think I have an image up of where I'm kind of headed on our if I if I go over here and leave this resource here for a minute. I have a finish, but on the actual assignment sheet, I think I have just an image of what my solid model ended up finishing at. And so if this is making sense to you, you can kind of just run, you can start running and putting some of these dimensions in, but oh yeah. Let's see here. I'll go back to that in just a minute. But here's where I'm going to start. This is what I'm building right now, right? Is like I'm building, here's the thing we just extruded. And I'll take a break actually once and then see what I'm going to add is I'm going to go to all those data sheets and start like looking for how, how these flanges need to be and maybe how tall my inlet needs to be and how long my discharge needs to be. Don't worry about the squared around here yet. Mostly I'm just looking at just trying to I'll just try to look for some dimensioning that's in this folder for how tall this stuff should be and what I'm going to use on the end here. And what I've done is I've kind of started solid modeling some of the, even though these are not parts that I'm going to use this as a base component, and then I'll just be able to jump in and pull these flanges off when I need them. These are stiffener flanges just to support the housing across that 8 foot span, so it doesn't like flex open. And so, what's that? They may that yeah there would be I think as a company you would have like hey we support every 4 foot or we support every 3 foot or something like that yeah I think in I yeah and and I would say this is pretty forgiving, and I just figured I needed two, and I might look in my resources and see in that manual if they talk about how maybe how often you should put one. It looks to me like I've almost and they almost don't look symmetrical, which kind of bugs me. I'd have to go look in mine and see. Because ideally, I think I don't know what I've got going on here, but
Is the week that the radius and or the width, I guess it's 11 inches.
yeah,
Is that the inside
that's the
dimension though?
inside of my trough.
So solid will be a dimension of the inside. So those outer branches actually work.
Yeah, if I'm accounting for some, so what I've got to think of here. Yeah, what I got to think of is what I skin. See, this is how I this is the first part I'm kind of trying to make is this sheet metal part, and it's like I've skinned my solid. So if I go
So
in
the solid model though, if you were to take the flanges off the solid model, then they would be too small of a
like right here, I think I've accounted for the material thickness being here. And so I've kind of strategically built these to be to account because what I'm going to do is I'm going to use the one we're just drawing, which is this one, and I'm going to think that I'm going to skin that thing.
yeah.
Yeah, so I'm going to use my sheet metal to skin this, and then I've got to factor that into, oh, now I've got to make that room adjustment on if I'm going to use this. And it wouldn't be that like a lot of people drafting might not put all this in this particular solid model. They might do that independently or something. But for whatever reason, when I was thinking about it, I was like, I think I'm going to put them in right here, and then I could just like derive in this part and pull in that, and essentially just create a solid from that, and create a part from that. It was really what I was thinking here. And even if I thought, well, it doesn't even actually live here on my model, well, then I could actually move that part where I really want it. But ideally, I would put it where I really want it here. And I'm looking at this thinking, what was I thinking? What was I thinking? Because I was thinking I don't know. I'll try to get into my brain again. But yeah. So what I want to do is there's the one we have. I think I want to take a quick break and then we'll start building out. Well, that's about it. We've only got to start on this. I do want to do some 3D derby car stuff, so let me do that. But this is kind of where I'm headed. I might populate some of the dimensions I've used, but all I'm doing is going to reference that SEMA chart and start building out this solid. That's kind of the first assignment I have is to get like the initial first housing solid modeled, and uh, and maybe I'll be able to jump into this once. I'll take a break and then I'll do a little bit of 3D derby car. And then maybe I'll even jump into this towards the end again and start drawing. So yeah, I'll call this my part one of housing solid. Let's take a break.